Welcome to the SIRE 2.0 inspection program and to the first in a series of guidance modules which have been developed by OCIMF to guide the industry throughout the transition from CVIQ 7 to SIRE 2.0. Launched in 1993, the OCIMF Ship Inspection Report Program, SIRE, has governed over 180,000 inspection reports and has made a significant contribution to improving overall safety within the maritime industry. As the industry continues to evolve, its risk profile changes, and with sophisticated risk measurement and management tools now available, OCIMF is strengthening the SIRE program to ensure it continues to remain relevant and effective for today and the future. OCIMF has developed an enhanced risk-based vessel inspection program, SIRE 2.0, that will replace the existing SIRE program. SIRE 2.0 inspections will provide OCIMF members and program recipients with more accurate information to enable them to make better judgments on quality and likely future performance of a vessel. Over time, the principles of SIRE 2.0 will be introduced in all of OCIMF's inspection programs, including the inspection program for barges, SIRE Cat 3, and the program for offshore vessels, the Offshore Vessel Inspection Database, OVID. In this module, we will explain the reasons behind the need for change from the existing CVIQ 7 inspections to the SIRE 2.0 system. This will bring about the step change that we hope will push the industry towards OCIMF's vision of an industry that causes no harm to people or the environment. We will discuss the 4 key areas of focus and the goal of an enhanced and risk-based vessel inspection program. A brief overview of the SIRE 2.0 question set, as well as a review of the inspection process, will be provided towards the end of this video. The need for change between CVIQ 7 and SIRE 2.0 were influenced by the following factors. 1. Feedback from the industry relating to the effectiveness of the SIRE CVIQ 7 program. 2. Many of the questions within the existing CVIQ 7 related to hardware. 3. Causes of incidents were not always related to hardware, but to human interaction with the hardware. The human element aspect of SIRE 2.0 will be covered in more detail in their respective modules. 4. Concerns were identified under the CVIQ 7 process that it contained too many questions and that questions were not targeted or focused on specific higher risk areas. Often questions in a CVIQ 7 inspection were not completed accurately and too many were answered as not applicable. 5. Critical operations were not able to be given repeatable coverage. Time management was not always consistent, with some inspectors completing an inspection in 6 hours and some in 14 hours on vessels of a comparable size. SIRE 2.0 – a step change. As we mentioned earlier, SIRE was launched in 1993 and has governed over 180,000 inspection reports. As a result, SIRE has made a significant contribution to improving the overall safety record of our industry and has received industry-wide acceptance and participation by OCIMF members, program recipients, and by ship operators. The current SIRE inspection program has concentrated on facilities, equipment, and management systems. SIRE 2.0 introduces a third element to the inspection program: human factors. As you progress through these modules, you will see that human factors is identified as a significant root cause of incidents, and going forward with SIRE 2.0, this will be an element that is identified within observations, along with hardware and process aspects. OCIMF's vision is that this addition of human factors in all its activities will further improve safety and reduce incidents. Let's look at the need for this change. In this transition from CVIQ 7 to SIRE 2.0, the following key areas were identified and will be addressed, with the aim of an overall reduction in the number of incidents. 1. The need to focus more on significant risks. 2. The need to link SIRE with TMSA objectives and KPIs. 3. The need to respond to technological and regulatory changes. 4. The need to streamline the overall process. 5. The need for inclusion of human factors in the risk-based approach. 6. The need to enhance governance control. These changes will be delivered via the SIRE 2.0 inspection program. The strategic goals and objectives that the SIRE 2.0 program aims to deliver on are identified by the following 4 key focus areas. Accuracy. Facilitating an accurate description of how key safety and operational risks are managed and verified on board a vessel. Capability. The training and development of inspectors who are of the highest quality, consistency, and integrity. Reliability. A strengthening of vessel inspections and reducing the number of repeat inspections required. Adaptability. A more rapid response to human factors, industry changes, regulatory framework updates, and technology advances. So how are we going to achieve these goals? Enhanced inspection criteria on equipment, procedures, and human factors to further improve control over vessel safety systems and processes. Enhanced pre-inspection processes and more robust monitoring protocols on the inspection process will be included. Significant enhancements to training and continuing development of inspectors to ensure the highest standard of delivery is maintained and improved. A more comprehensive inspection regime with enhanced tools, strengthened governance processes, and more in-depth reporting outcomes following a risk-based approach. Updated policies, procedures, and user guidance housed in an online process documentation library. An enhanced governance process to provide greater transparency and control for all parties involved in the program, either directly or indirectly, and the adoption of rules that are enforceable and verifiable by OCIMF. The use of web-enabled tablet devices to allow inspections and feedback to be reported and documented in real time, and to allow inspections to be completed more efficiently with the adoption of a comprehensive yet standardized reporting format. The question set development and review process has been conducted over a 5-year period and has involved numerous stages of approval that has included 1. A review by the Inspection Working Group. 2. A review by subject matter experts, made up of members, auditors, and inspectors. 3. A review by the Human Factors Committee. 4. A review by the Legal Committee. 5. A review by OCIMF members. 6. A review by industry representatives. The final compilation and publication were done only after these 6 reviews were completed. Now let us go through an overview of the inspection process. The inspection request and validation. All inspection requests will be made through the OCIMF portal. Requests will be validated against the program's rules to ensure that only compliant and qualified inspectors are nominated. The pre-inspection preparation. The inspection template will be populated prior to the inspection from sources of information including vessel particulars, certificates, pre-inspection questionnaire, past inspection observations, port state control data, incident data, relevant photographs and plans. This information will also be available to the inspector before they board the vessel. The risk-based vessel inspection questionnaire. A bespoke risk-based vessel inspection questionnaire will be generated. Questions will be of 4 types. Core. These are the minimum questions required to meet the members' fundamental risk assessment criteria. Rotational. These are all those non-core questions that are included in the questionnaire over a defined period. Conditional. These are specific questions that are included based on the data available for the vessel, the operator, or the ship type. Campaign. These are questions that cover areas of specific focus identified by OCIMF or its membership and will be included in all questionnaires over a limited time period. The inspector's preparation. The inspector will review and analyze the data provided on the vessel in advance of the inspection. Executing the inspection. All inspections will be carried out using a tablet device that is fully compliant for use on board all vessel types. The use of the tablet will improve the overall quality of the inspection report and resulting marine assurance data, facilitate the expanded inspection template, and support the delivery of the 4-tier question set. provide photographic verification to support the findings. Allow tracking, auto-logging of start and finish times, and auto-submission of inspection reports. The inspection report. When giving a non-compliant observation, the tablet will automatically open an editor that allows a granular assessment of the observations, including a breakdown by equipment, procedures, and human factors. Each inspector will be given the opportunity to assess observations against grades of yes when providing positive observations. That concludes this video. We have looked at the reasons behind the need for change from the existing VIQ 7 inspections to the SIRE 2.0 system, and we have detailed the 4 key areas of focus and the goal of an enhanced and risk-based vessel inspection program. Thank you for watching. In this module, we will cover the different components of a SIRE 2.0 inspection to give you a greater insight into the SIRE 2.0 inspection process, including the benefits that the SIRE 2.0 inspection process will bring to the industry, the main differences between the present VIQ 7 inspection process and the new SIRE 2.0 inspection. Each inspection will have a bespoke question set. We will look at the way the questions are compiled and allocated to an inspection based on information supplied by the operator of the vessel, the structure of the questions, and the way that the hardware, process, and human elements of the questions are to be answered, going away from the traditional binary yes-no answers and introducing the concept of a graduated response and the addition of photograph validation questions, the contents of the negative observation module, and an insight into the subject of concern and nature of concern. And finally, we will look at the information that will be supplied by the operator to enable accurate compilation of the question set. The OCIMF Enhanced Vessel Inspection Program will focus on improving and strengthening vessel inspections by implementing a number of initiatives, including a bespoke, ship-specific set of questions for each vessel inspection called the Compiled Vessel Inspection Questionnaire (CVIQ), with all questions applicable to the type of vessel and cargo. Questions answered from a separate hardware, process, human factor, and photographic perspective. An observation rank of positive, neutral, or negative within SIRE 2.0. The term observation, therefore, means any response entered in a response tool. The opportunity for inspectors to assess and write observations using grades of yes. When writing an observation on non-compliant situations, the editor will allow the inspector to write a granular assessment of the observation, including a breakdown by equipment, procedures, and human factors. Detailed and codified negative observations, allowing for systematic comparison and data mining across inspection, vessel, and fleet. The ability for the reader of the final report to assess the physical and cosmetic condition of the vessel being inspected, rather than the inspector attempting to make a subjective evaluation of condition during the inspection. This is the primary intention of the photographic question set. A standard set of photographs required to be provided by the operator, which are made available to the inspector prior to the SIRE 2.0 inspection. Information received from the operator is integrated into the system prior to the compilation of the CVIQ. Now let us look at the main differences between VIQ 7 and SIRE 2.0. Included questions. The VIQ 7 inspection had a fixed question set for the type of vessel and variant that was selected, with question sets comprised of approximately 300 to 400 questions. Many of these questions were answered as not seen or not applicable, thus adding no value to the end report. The number of questions in a SIRE 2.0 CVIQ question set has been significantly reduced, with questions included according to the risk that they address. All question sets are compiled based on the data provided by operators in the Harmonized VPQ, HVPQ, and the Pre-Inspection Questionnaire, PIQ. This removes the need for the not applicable, NA, and the not seen, NS responses in a report. Structure of the question's answer options. All questions in a VIQ 7 inspection required a simple yes-no binary response, with supplementary options for not applicable, NA, or not seen, NS. The SIRE 2.0 inspection has moved away from the existing VIQ 7 question styles, with questions that now require graded responses for hardware, process, and the human factor elements of each question. The inspection also requires the inspector to validate photographs submitted by the operator. Negative observations. Observations made under VIQ 7 inspections are comprised of free text only, with no option for the inspector to provide media content. SIRE 2.0 observations identify a subject of concern and nature of concern, and have a photographic evidence function to support question responses. Data provided by vessel operator. In addition to the information provided in the HVPQ, the crew matrix, the PSC, and incident databases, SIRE 2.0 includes the standard set of vessel photographs and pre-populates inspection questions from PIQ information. So, what questions are included in the inspection? A bespoke question set is created for each SIRE 2.0 inspection and requires the vessel operator to provide information by the following means: the PIQ, the Pre-Inspection Questionnaire; the HVPQ, the Harmonized Vessel Particulars Questionnaire; a standard set of photographs; certificates from a defined list; an inspection declaration, where the operator confirms that all data, photographs and certificates provided are accurate, complete, and are in accordance with the instructions provided. Based on the information provided, the inspection compiler creates a unique ship-specific inspection questionnaire, the Compiled Vessel Inspection Questionnaire, CVIQ. The compiler assesses the vessel type and its inspection history, and then selects questions from the question library based on their risk ranking. All questions require responses on the hardware, process, and human factor elements. These responses will be graduated and supported with documentary evidence. The CVIQ and the information provided through the pre-inspection questionnaire are downloaded to the inspection editor on the inspector's tablet. The expected duration of a SIRE 2.0 inspection is spread over the different areas of the vessel to ensure a balanced allocation of questions for each area. A risk-based vessel inspection questionnaire is generated consisting of bespoke, risk-based vessel inspection questions using the bow tie methodology of risk assessment. Questions are comprised of 4 different types. Core: the questions required to satisfy members' fundamental risk assessment criteria. Rotational: the compiled questionnaire ensures that all non-core questions are covered over a period of time, and that each inspection template is designed for a defined duration. Conditional: specific questions based on the available data on the vessel, the operator, or the ship type. Campaign: questions based on areas of specific focus that may be identified by OCIMF and its membership and are applied over a limited period. Let's look at how the questions are structured. Each question is assigned one or more response tools to record the outcome of the inspection activity related to the top-level question. Hardware response tool: where a top-level question or supporting guidance refers to vessel structure, machinery, outfitting, or equipment, the hardware response tool is assigned. In most cases, the hardware response tool assigned is binary, since if vessel structure, machinery, outfitting, or equipment inspected under the scope of the top-level question is found to be deficient in any respect, the response is usually negative. Process response tool: where a top-level question or supporting guidance refers to a vessel procedure or documented process, the process response tool is assigned. There are questions where the guidance requires a binary response against a process-based question. In these cases, the response should be based on the top-level question being answered and the instructions provided in the guidance. Most questions that refer to vessel procedures or documents present require a graduated response. Human response tool: the human response tool is assigned where a top-level question or supporting guidance refers to the familiarity of vessel staff with a company procedure, process, or with the use or operation of machinery or equipment. Inspectors will consider whether the underlying task or activity was performed in an appropriate manner that is in accordance with company procedures, operating instructions, and/or industry best practice. These response tools may be programmed to require either a binary or a graduated response by the inspector. Where a binary response is required, the well-established SIRE yes-no convention is used by providing two options which are phrased to indicate yes or no within the context of the response tool. Where a graduated response is required, specific guidance is provided for each type of response tool. Continuing with the structure of the questions, let's look at what a photograph comparison response tool actually is. Where a top-level question refers to one of the standard photographs provided by the vessel operator prior to the inspection, a photograph comparison tool is assigned. The intention of the photograph questions is to allow the reader of the final report to assess the physical and cosmetic condition of the vessel being inspected, rather than the inspector attempting to make a subjective evaluation during the inspection. If the photograph is not representative of the general area, the inspector will provide photographic evidence along with any comments or observations, highlighting the actual condition of the area represented by the operator-supplied photograph. The contents of a negative observation. A negative observation made in SIRE 2.0 is a combination of a subject of concern and a nature of concern. Subject of concern, SOC, is a term used within the inspection editor application to identify what is being reported on. Nature of concern, NOC, a term used within the inspection editor application to identify what has been observed. The use of the EX-Proof tablet allows the inspector to take and provide photographic verification to support their findings. This use of the tablet will be subject to terminal vessel approval. The photograph repository. The vessel operator uploads a defined set of photographs of the vessel to be inspected. These will be used for condition verification by the inspector during the inspection and will be included in the final report for the information of the report recipient. Vessel certificates. The vessel operator uploads vessel certificates applicable to the inspection process from a defined list. The certificates are available to the assigned inspector through the inspection software before the inspection. HVPQ. A questionnaire for documenting and communicating permanent and infrequently changing information about a vessel, its construction, outfitting, and certification. Information from the HVPQ is used to auto-populate some aspects of the inspection report and to manage the assignment of some questions. The crew matrix. The operator maintains a record of the officers and crew on board. This information is available to the inspector before the inspection. Pre-inspection questionnaire, PIQ. An online questionnaire completed by the vessel operator that provides information about the vessel and supplements the information provided in the Harmonized Vessel Particulars Questionnaire, HVPQ. The PIQ is used to gather dynamic information about vessels' operational history and additional static data. This permits the inspection compiler to assign questions when building a bespoke inspection questionnaire for the inspection. Some of the information gathered through the PIQ is inserted into the inspection editor and the final report as information for the inspector and report recipient, respectively. The PIQ is not available as a standalone document. In this module, we have looked at benefits of SIRE 2.0 to the industry, differences between VIQ 7 and SIRE 2.0, what questions are included in the inspection, how the questions are structured, contents of a negative observation, operator-supplied content. This brings us to the end of this module, which has briefly introduced us to the components of the SIRE 2.0 inspection. Further modules are available that cover other aspects of the SIRE 2.0 program. Thank you for watching. In this module, we will cover the risk-based approach taken by a SIRE 2.0 inspection and the use of the bow tie methodology to generate a bespoke risk-based vessel inspection questionnaire. This video will give you a greater insight into the technical aspects of a SIRE 2.0 inspection process. We will look at the concept of the risk-based approach used in the development of the question sets, the ranking of questions based on the risk that they address, the use of the bow tie methodology, and the question types. Let us first look at how we set about bridging the gap between a SIRE VIQ 7 inspection and a SIRE 2.0 inspection. To do this, we must first remind ourselves of the characteristics of the current SIRE inspection based on a VIQ 7 questionnaire. The question style requires a binary response. The questionnaire contains a large number of questions, too many questions being answered as not applicable. This is a paper-based inspection. The questionnaire provides limited guidance to the inspector. The question sets are fixed for every inspection. A risk-based approach to SIRE 2.0 inspections will mean inspectors complete a compiled vessel inspection questionnaire (CVIQ) that is generated using a sophisticated algorithm to create a bespoke questionnaire for each inspection. The inspection will be completed in real time using a tablet device. The key features of a SIRE 2.0 inspection are a tablet-based inspection, an enhanced question style, a unique inspection template, comprehensive inspector guidance provided with each question, a comprehensive observation reporting tool that includes graduated responses, and the provision of photographic content to support observations. So how will SIRE 2.0 with the risk-based approach enhance marine assurance processes? It will provide significantly improved data quality with a specific focus on processes, equipment, and people. More detailed, reliable, granular, focused, and comparable information. Observations that are set in a meaningful context to allow for analyzable root cause analysis. An integration of information records, including photography, the harmonized VPQ, PSC reports, crew matrix, and incident data. Expanding on the risk-based approach. Defenses, barriers, and safeguards occupy a key position in the risk-based approach. Systems on board have many defensive layers. Some are engineered, for example, alarms, physical barriers, automatic shutdowns, etc. Others rely on the actions of people guided by procedures and administrative controls. Barriers protect potential threats from becoming hazards. In most cases, they do this very effectively, but there are inherent weaknesses. In an ideal world, each defensive layer would be intact. In reality, however, they are more like slices of Swiss cheese, having many holes, though unlike in the cheese, these holes are continually opening, shutting, and shifting their location. The presence of holes in any one slice does not normally cause a bad outcome. Usually, this happens only when the holes in many layers momentarily line up to permit the trajectory of an accident to pass through, resulting in the threat becoming a hazard. The holes in the defenses arise for two reasons: active failures and latent conditions. Nearly all adverse events involve a combination of these two sets of factors. Active failures are the unsafe acts committed by people who are in direct contact with the system. They take a variety of forms: slips, lapses, fumbles, mistakes, and procedural violations. Active failures have a direct and usually short-lived impact on the integrity of the defenses. So often failures are blamed on the people involved in the task, and quite often, once these unsafe acts are identified, no further investigations for the causes of an adverse event are pursued. But virtually all such acts have a causal history that extends back in time and up through the levels of the system. Latent conditions are the inevitable resident weaknesses within the system which exist as a result of decisions made by designers, builders, procedure writers, and top-level management. All such strategic decisions have the potential for introducing weaknesses into the system. Latent conditions have two kinds of adverse effect. They can translate into error-invoking conditions within the local workplace, for example, time pressure, understaffing, inadequate equipment, fatigue, and inexperience. And they can create long-lasting holes or weaknesses in the defenses, untrustworthy alarms and indicators, unworkable procedures, design and construction deficiencies, etc. Latent conditions, as the term suggests, may lie dormant within the system for many years before they combine with active failures and local triggers to create an accident trajectory. Unlike active failures, whose specific forms are often hard to foresee, latent conditions can be identified and remedied before an adverse event occurs. Understanding this leads to proactive risk management. We cannot change the human condition, but we can change the conditions under which humans work. Bow tie methodology, on the other hand, is a risk model used to assist the identification and management of risk. All SIRE 2.0 questions were developed using this tool. This methodology is a core part of the treatment of risk, particularly where there is a high level of risk or where control effectiveness is assessed as low. A bow tie is a graphical depiction of pathways from the causes of an event or risk on the left to its consequences on the right in a simple cause-consequence diagram, where the knot of the bow tie depicts the top event and is the point where the pathways converge and the mitigation pathways spread out. The focus of bow tie analysis is either on the barriers or controls depicted to the left-hand side of the knot, or the top event that impact the likelihood of the event or circumstance, or on those on the right-hand side that address the mitigations of the consequences. It is used when assessing the completeness of controls to check that each pathway from cause to event and from event to consequence has effective controls. This enables factors that could cause controls to fail, including management systems failures, to be recognized. OCIMF developed bow tie models for several areas of marine operations to assist in the identification of priority threats and barriers that would prevent loss of control of activities related to process, personal safety, or reputational issues. The Inspection Working Group used bespoke bow tie software to map all activities identified with the loss of process safety within OCIMF bow tie models on tanker, barge, and terminal operations. As we know, the focal point of a bow tie is the hazard, which is something that has the potential to cause harm or trigger an event. However, for that to happen, something must occur that allows the hazard to evolve and result in the event taking place. The example of a hazard shown is volatile hydrocarbons under pressure in a pipeline, and the event is the loss of containment. The threats could be pipeline failure due to external corrosion or overpressure due to thermal variation or upstream emergency shutdown (ESD), the consequences of which could be fire or explosion, personal injury, and/or environmental pollution. After identifying the hazard, the top event, the threats and the consequences, preventative barriers can be identified. The process is repeated for the right-hand side of the bow tie, this time identifying controlling barriers to mitigate the consequences if the event was to occur. The focus of bow tie analysis is on the barriers depicted to the left-hand side of the knot that can change the likelihood of the event from occurring. These are proactive actions, or those on the right-hand side that can mitigate consequences after the event. This methodology allows the assessment of the completeness of barriers to ensure that each path from cause to event and event to consequence has effective control barriers, and that factors that could cause controls to fail, including management systems failures, are identified. The identification of areas of marine operations and the identification of priority threats and related barriers that would prevent loss of control of activities related to process safety, personal safety, and/or loss of reputation took approximately 2 years with over 100 participants from the OCIMF membership involved. Let's look at a marine-related example and the preventative barriers that can be put in place to minimize the risk of collisions, elisions, and groundings. So, what are the preventative barriers that we can put in place to minimize the risk of collisions, elisions, and groundings? You can see that 6 barriers have been identified. So, if we were using the Swiss cheese model, then, in this example, there would be 6 slices of Swiss cheese or barriers. Let's now take the first barrier, which is maneuvering the vessel clear of danger. The barrier is described in detail, and in this case, it states, the intent of this barrier is to ensure that the vessel is always able to maneuver clear of any threats or hazards. Just below the barrier description is a list of non-exhaustive barrier controls, such as what critical equipment and controls are in place to maneuver the vessel clear of danger: the main engine, steering gear, generators, ECDIS, ARPA, azimuth bearings, echo sounder, and anchor and windlass. These critical equipment and controls can be expanded into sub-barriers. Expanding on the navigational equipment, we get sub-barriers such as gyro error checks, use of passage plans, navigational audits, application of the rule of the road, effective lookout, use of tugs, UKC calculations, adhering to CPA, etc. So you can now see how the use of the bow tie risk assessment method allows us to identify and expand on each threat barrier. The level of granular detail to which the identification of priority threats and the implementation of related barriers was taken can be seen in this graphic. Let's summarize what barriers are all about. They are pivotal in preventing a direct link from a threat to a top event, a direct link from the top event to the consequence if the top event was to occur. They could be hardware in the form of technical measures, for example, equipment or structures. Process in the form of organizational measures, for example, procedures. People in the form of personnel who design, operate, maintain, monitor, and manage processes and procedures. Bow ties and barriers offer the following advantages. Risk-based decision-making. They allow the check on whether there are enough barriers to mitigate the risk appropriately. Barrier dependency visualization. They allow the visualization of what may happen if the resource responsible for multiple barriers is compromised, e.g. the chief engineer is ill or power is lost. Enables risk assurance. They allow a check on the performance of the barriers. Informed decision-making. They allow a check on what might happen if a barrier is removed or degraded. Risk-based management. They allow for the identification, analysis, evaluation, and treatment of threats and barriers. It is recognized that by identifying the correct barriers and testing the barriers for effectiveness, these barriers could be a highly effective method in monitoring the potential for a top event. SIRE 2.0 will not follow a standard question set for each inspection. A question library of inspection questions has been created to allow an inspection compiler to construct a unique, ship-specific set of questions for each vessel inspection, called the Compiled Vessel Inspection Questionnaire (CVIQ). All questions were ranked using the bow tie risk analysis to ensure that emphasis is placed on critical barriers and activities during the inspection process. This ranking of questions on the basis of risk allowed for each question to be assigned to the following categories. Core – questions that will be assigned to every inspection. These address barriers protecting critical activities. Rotational – questions that are non-core and are assigned to a vessel inspection in the following manner. Rotational 1 – every third inspection. Rotational 2 – every sixth inspection. Conditional – questions specific to the vessel, the operator, or the ship type that are based on data available for the vessel. These help to assess an operator's level of attainment against TMSA as declared by them in the Pre-Inspection Questionnaire (PIQ). Campaign – an existing rotational question assigned to every inspection for a fixed period in response to an incident or industry trend. Where no suitable rotational question exists, a new question will be developed for inclusion in the SIRE 2.0 question library at the next revision. Some facts about core questions. Core questions will be allocated to every inspection. Approximately half of the questions in the compiled questionnaire will be core. Core questions will be allocated for vessel type and operation, from information declared in the PIQ. Negative observations under core questions raised in the previous inspection will be detailed in the subsequent inspection. This ensures the weakness of critical activities are properly resolved. Campaign questions will be treated as core questions for the duration of the campaign. That concludes this video. In this module, we have looked at the following aspects of the risk-based approach to the SIRE 2.0 inspection process. Bridging the gap between VIQ 7 and SIRE 2.0 and the risk-based approach. The Swiss cheese model. Bow tie methodology. Question styles and how they were developed taking into account their risk ranking. Thank you for watching. In this module, we will talk about the different question types used in the SIRE 2.0 inspection process. These are core questions, rotational questions, conditional questions, campaign questions. All questions have been ranked against risk using OCIMF's bow tie risk analysis to ensure proper emphasis is placed on critical barriers and activities during the inspection process. Core questions. These questions address barriers that protect critical activities and will appear in every CVIQ. Rotational questions. These questions address barriers that protect priority activities and are further categorized into two subcategories. These questions are rotated through subsequent inspections. Conditional questions. These questions are generated on the basis of information provided by the operator through the PIQ and the HVPQ and help assess an operator's level of attainment against their TMSA declarations. Campaign questions. These are questions that are generated in response to issues and emerging industry trends that may be identified by OCIMF or the members. Campaign questions appear in all inspections for the duration of the campaign. SIRE 2.0 will not follow a standard question set for each inspection. A question library of completely refreshed inspection questions has been created to allow the inspection compiler to construct a unique, ship-specific set of questions for each vessel inspection called the Compiled Vessel Inspection Questionnaire (CVIQ). Remember, questions are set up to maintain the health of priority barriers. Core questions will be allocated to every inspection. These will be applicable to the vessel type and its operation. Core questions protect barriers that address critical activities. Rotational questions are those non-core questions that are assigned to a vessel. There are two types of rotational questions. Rotational 1. These are questions that are scheduled every third inspection. Rotational 2. These are questions that are scheduled every sixth inspection. Conditional questions are generated on the basis of information provided in the PIQ that help assess an operator's level of attainment against TMSA declarations. Campaign questions are those that address issues and trends within the industry and can be generated using either existing rotational questions or, where no suitable rotational question exists, a new question will be developed. These questions are assigned to every inspection for a fixed period in response to an incident or industry trend. A final review of some facts on core questions. These questions maintain the health of priority barriers. Core questions will be allocated to every inspection. Approximately half of the compiled text questions will be core. Core questions will be allocated for vessel type and operation from information declared in the PIQ. Negative observations under core questions raised in the previous inspection will be detailed in the subsequent inspection. This ensures the weakness of critical activities are properly resolved. Campaign questions will be treated as core questions for the duration of the campaign period, i.e., they will appear in every inspection for the duration of the campaign. To recap, in this video we have covered the following aspects of the SIRE 2.0 inspection process: core questions, rotational questions, conditional questions, campaign questions. Thanks for watching. This module will cover the type of question guidance available in the SIRE 2.0 inspection question set, including the guidance provided with each question, the actions that the inspector is expected to take, the evidence expected to be submitted, and the potential grounds for negative observations. Every question and the supporting guidance have been developed using a standard template with guidelines for completing each section and element. To ensure that a question is managed properly within the SIRE 2.0 software, a number of attributes have been identified and set out. Question number and question group. Used to set out the chapter, section, and sequential number. Also used to manage groups of rotational questions to maintain a balanced question allocation. Question area. Used to manage time allocation to a defined area on board the vessel. ROVIC sequence. Used to identify the physical location on board where the question will be displayed by the inspection editor software. Response type. Used to ensure that the required response tool is presented by the inspection editor software with the following options: human, process, hardware, photo validation. Question type. Used to manage the allocation of questions by frequency or conditionality. Core, rotational 1. rotational to, campaign, conditional. Vessel type. Used to identify the type of vessel and operation that a question may apply to. For example, oil, chemical, LPG, LNG. Input material. Used to identify the locations from where additional input material will be sourced. For example, Vessel's Particulars Questionnaire, VPQ. Used to identify questions that will be allocated or managed based on specific information provided within the VPQ. PSC Inspection Repository. Used to provide a link to search for data in the OCIMF PSC repository. Publications. Used to make an association with the publications database for updating purposes. Document store. Used to link vessel certificates and documents for display in the inspection editor. Pre-inspection questionnaire. Used to link information provided by the vessel operator relating to the operational history and performance of the vessel. Also used to resolve ambiguities to assist in question allocation. Testing and approvals. Used to identify and record the approvals of the participating working groups, the steering group, and the subject matter expert before the question is finally ready for inclusion in the library. Every question and the supporting guidance have been developed using a standard template with guidelines for completing each section and element. The question structure provides a clear understanding to all program participants regarding what the question addresses, what industry best practice, rules and regulations and inspection guidance should be considered when assessing the issue, what issues and operations the inspector is expected to consider and assess, what evidence the ship may be asked to provide, what circumstances may lead to a negative observation. All questions in the library have been ranked using OCIMF's bow-tie risk analysis method and have human, procedural and hardware elements. Each SIRE 2.0 question is constructed with the following components. The top-level question. This provides an overview of the purpose and scope of the question itself. The abbreviated question text. This is used in the ROVIC and chapter mode displays to help the inspector quickly interpret which questions are included in the CVIQ. The objective. This provides a statement identifying the purpose of the top-level question. The inspection guidance. This provides an overview of expectations from the vessel's safety management system and carries forward any previous SIRE guidance that is considered to be a standard inspection requirement. Here we will look at an example of a question, its structure and guidance. The top-level question in this case is, were the master and officers familiar with the company procedures for the safe operation of the ballast water management system (BWMS), and was the equipment in satisfactory condition and used in accordance with the company procedures and manufacturer's instructions? The shortened or abbreviated question which helps prompt the inspector in this case is Ballast Water Management System (BWMS). The objective here is to identify the overall purpose of the top-level question, in this case, to ensure that ballast is always handled safely in accordance with company procedures and manufacturer's instructions. The guidance to every question is structured in the following manner. Industry guidance. This contains the industry best practice guidance, any relevant OCIMF publications and papers, the most relevant TMSA KPIs, any applicable rules and regulations, for example, SOLAS, MARPOL, IGC or IBC codes, etc. Remember that this is not an exhaustive interpretation of industry guidance. Inspector guidance. The guidance in this section is used to provide a basic framework for what actions the inspector should consider when addressing the top-level question. For example, cite and where necessary, review. Inspect the visible part of. Where necessary, review the maintenance records. Expected evidence. This section provides a list of the documentary evidence that should be made available to the inspector during the inspection process. The inspector may request further unlisted evidence to assure themselves that the top-level question has been addressed. The list of expected evidence should not be considered as exhaustive. Evidence should be made available according to the guidance supporting a specific question, or where no guidance is provided for the previous 6 months or since the last SIRE inspection, whichever is more recent. Potential observations. This section provides a list of the circumstances in which the inspector may consider entering a negative observation. The list is not exhaustive, but is representative of the most likely grounds for a negative observation based on the associated question guidance. For every question, there are 3 tabs. 1. Operator-supplied content. 2. Guidance. And 3. Responses. Within the Guidance tab, the inspector will find the 4 basic areas of guidance, which include 1. The guidance section that provides the objective, the associated best practice guidance, the most applicable TMSA reference, the most applicable ISM reference, and any applicable regulations. 2. The suggested inspector actions to help the inspector to verify that all aspects of the top-level question and the guidance section have been addressed. The suggested actions list is not compulsory and only needs to be completed to the point the inspector is confident the required responses can be completed. 3. The expected evidence to help understand the documentary evidence that should be made available during the inspection. The inspector may request further unlisted evidence to assure themselves that the top-level question has been addressed. The list of expected evidence should not be considered as exhaustive. Evidence should be made available according to the guidance supporting a specific question, or where no guidance is provided for the previous 6 months or since the last SIRE inspection, whichever is more recent. 4. The potential grounds for an observation details circumstances under which the inspector may consider entering a negative observation. The list is not exhaustive, but is representative of the most likely grounds for a negative observation based on the question guidance. In this module, we have looked at the type of question guidance available in the SIRE 2.0 inspection. These included the guidance provided with each question, the actions that the inspector is expected to take, the evidence expected to be submitted, and the potential grounds for negative observations. Thanks for watching.